Hi there, I'm Scott Jones, and today I'll be presenting my Lab1 video report on constant velocity motion. So yeah, get excited. Woohoo! So in this lab, I observed an orange ball rolling across a sheet of white paper. And for simplicity's sake, we can say it's moving in the positive x direction. The main result that came out of this was, upon assuming the net force on the ball was equal to 0, the model made a fair prediction of the motion of the ball across the paper. Now, here is the original video of the orange ball being hit and given an initial velocity, which theoretically should remain constant from then on. Now here is the modified video applying some of the fancy stuff on the tracker program. I started by making an axis where the original position of the ball was, right here, and then tried to keep it through the center of the ball as it moved across the sheet of paper. I used a calibration stick up here to find the diameter of the ball, which was 0.035 meters, and this was used to set the length scale of as the video goes on. Then I took the ball's center, or as close to it as I could, as the average position, which will be shown by this little red circle as the movie is played, and the total time this clip takes is approximately 1.3 seconds. So as you can see, it's not completely straight, just because of human error. It's kind of hardened. The ball technically doesn't go in a perfectly straight line, but as you can see here, it's generally linear, and that's what we're hoping for here. So, in order for me to find the initial velocity, I needed to know the change in position, which I found using the tracker program, and also the change in time, which, as I said previously, was approximately 1.3 seconds. And then I just applied the simple formula, the initial velocity is equal to the change in distance over the change in time, shown here, and I found the initial velocity, or the estimated initial velocity, to be approximately 0.206 meters per second. So now we turn to the VPython program, and here's a snippet of the code that I used. In order to solve for the final velocity, I need some of these following initial conditions. The ball's mass is needed, and this is 0.0427 kilograms. I just found that number from online. And then the initial conditions for the position is just saying the origin is at 0, 0, 0. And then the ball's initial velocity, which I found on here, in the x direction, the positive x direction only, made the vector here at 0.20600. And of course the start time is 0, and the delta t, I made it small compared to the 1.3 seconds, just so I could have enough